Hi, everybody. Hope you can hear me. My name's Stephen Barrett, CTO of Milestone. Delighted you could join us from wherever you are. So good morning, good afternoon, good evening, wherever you are. Um, this talk is going to be about an area that we're working in a lot. We're going to take a sort of a view on AI usage in particular kinds of organizations. And our view is that engineering is, obviously innovating and massively impactful in organizations, but there are also governance consequences with this and with the organizations that we're working with. We're seeing this, and we want to talk through the kind of issues that arise and the strategies that we think organizations can usefully use in order to manage this. So the key issue is how to keep the benefits of AI productivity gains while also staying in control and owning the outputs and the code bases. So a little bit about us. So Milestone, we have a platform that helps companies measure how Gen AI impacts engineering. Primarily targeted at leadership to help leadership make better calls. So we kind of analytics over Gen AI data sets. We tend to work, and there's a selection of companies on this slide here. We tend to work with companies that are kind of doing mission critical kind of work at scale. So that's how we see this. So there's lots of ways of thinking about AI productivity. All from one shot all the way to the kind of the space that we're in, which is that AI is seen as a really, really important technology, but that its benefits have to be balanced against the other mission critical aspects of an organization, like, for example, sense safety in the enterprise context. So this talk, I hope I'm not going to take it too long with you. It should maybe about 40 minutes or so. There are kind of five themes, five stages to it. The first thing I'm going to do is I'm going to survey with you the sort of the production model shift underway. And I should also add, like, if you have questions, fire them into the chat session. We'll try and deal with them as they come up, and definitely try and deal with them before we finish. So if you have any particular questions, please ask away. So we're going to survey the production model. We're going to look at the shifts that are underway there. I want to look at what this means for knowledge, for an understanding of the code base, for the sort of the intuitive sense of the assets of the organization, and how LLMs align to that. We're going to ask how that changes metrics. Engineering has a lot of metrics. We've DORA metrics and a whole range of other metrics that try to qualify the engineering performance and the teamwork that goes on in software engineering. And we're big advocates of all of that. But what we find with AI coming on the scene is some of those metrics, the meaning drifts, and I'll get into what that's about. I'm going to settle down on sort of the fourth section, and hopefully we'll get there fairly quickly, is the issue of oversight, and that the exposure that an enterprise needs to worry about is that a loss of oversight, that yes, we're getting massive productivity gains and so on, but we don't really know what's going on in terms of how that is landing. Yes, we're getting faster code, but is our code base becoming more fragile? Those kinds of issues. What I hope to lead you to, hopefully not being dragged, but hopefully you'll agree at the end of the day, is that this needs a more active view of what governance is. That AI is such a transformative technology that it changes a lot of the rules about how management needs to be done, and we need to get into a much more investigative approach to managing software engineering. Let's start with something really uncontroversial, straightforward. AI is embedded in engineering. I don't think anybody at any organization doesn't, unless some edge cases, wouldn't agree that today AI is being used to do a lot of the work that engineers used to do. So it's doing real work. It's refactoring. It's writing test code. It's even making architectural suggestions. This is not an unsophisticated technology. This has, especially over the last let's say 6 months, has graduated from maybe toy examples to real technology that can be used in production in anger. PR review technology has emerged. There's lots of uses, and every week we're getting a new way of using AI to take the load, or in some cases entirely replace the activity of engineers. All the way up through to upcoming agentic systems. Having said that, I think it's also true to say, certainly amongst the organizations that we work with and talk to, usage is uneven. That AI is definitely on the plan of everybody, but that plan is at different stages of evolution. And often that's not about organizations being slow to the table. That often is about organizations having certain criteria, certain secondary issues that they need to resolve, more complex scenarios than your classic startup throwing out as much code as possible, as quickly as possible. The key shift, I suppose, if we were to sum what is AI delivering, it's making the individual engineer incredibly more impactful. And I think that's happening in two ways. I mean, obviously, an engineer can generate more code. That's very straightforward. AI can produce code far faster than an engineer individually without that technology can do. But the technology is also being used on the other side to help engineers understand existing code bases. So the surface area, if you like, the range of areas of the code base that an engineer can usefully contribute to with AI in place is increasing as well. So AI is becoming this kind of mediating technology that is enabling the engineer to scale out their impact, both in terms of pure volume, but also in terms of applicability across the organization. So you increasingly see organizations who are making heavy use of AI break down barriers over who can change what, and expertise is easier to move, easier to relocate from place to place. So, bottom line is AI is in the delivery pipeline. Most organizations we deal with, obviously, we're an AI enablement platform, so it's going to be a slight selective bias, but almost every organization we speak to is these days already using AI and just wants to get a better handle on how to deal with some of the kind of problems that we're going to talk about today. Okay, so let's kind of set a frame for the kind of AI usage that's happening, just so we can then talk about some of these other issues. We have a 4-layer model here. So assistive, generative, orchestrated, and agentic. And this ranges from code completion. That's the basic. Everybody remembers the early days of these technologies when you could tab and get some extra stuff out. And you could also ask, in the IDE, you could ask, what does this code do, and get those kinds of responses. So that's your baseline. Everybody's doing that. I think we can swiftly move on from that. Most organizations are moving on to generation of actual code. Now, so this would be the case where the engineer with the IDE is asking the AI to provide code, typically diffs that end up getting implemented into the code base. It is a chat, it is a communication. The engineer is working with the AI alongside the AI in order to generate the outputs. And from our perspective, the engineer is to a large degree in control there. I think when they start generating test suites, probably not so much, because engineers tend not to look too closely at that. So there are definitely people who are generating lots of test code alongside where they're focused. So that even there, you're starting to see potentially a shift in where engineers are spending their time. But broadly, what we're talking about there is the engineer in control, working with the AI as an assistant. The next layer is, and we're seeing this in some companies, extremely sophisticated use of prompt-led workflows. So we're talking here about repositories of prompts where prompts are used at different stages of the development cycle. and a lot of this content being developed collaboratively over time by engineers as they find ways of capturing organizational context to some degree, and that's really interesting. And I think largely to date, kind of bleeding edge. Now, there is obviously the agentic piece. From what we've seen, that's kind of rare. So this is the kind of scenario where I think we're going beyond just long plans that take an IDE or sorry, an AI tool, typically in an IDE or maybe something like Codex, a long time to do. We're talking here more about handing over the development process to fleets of agents that collaborate amongst themselves in order to take over the engineering function largely, with maybe some level of oversight by engineers. That's pretty rare, but definitely while it's the business model of most of the AI labs, so it's coming down the tracks. There are, I think, two kind of patterns to be seen in this. So the first is, and I mentioned it slightly already, but as you move down that track, the surface area of where an engineer can work expands. So the range of parts of the code base or code bases spreads because their engineering skill can be applied in this mediated way to the task at hand. So that's a positive. There is a negative, and the negative is as engineers rely on this technology to mediate to the code bases, their understanding of those code bases is diminishing. And I think that's without putting in place specific measures, that's just going to happen. It's a consequence of where engineers are spending their time. They're not struggling against the code base and understanding how to make things work. The AI is doing that for them. They didn't learn about those aspects of let's say, the architecture of a system or so on. Kind of like working through junior engineers. The junior engineers are learning all of that stuff. You're not necessarily. Now, that may work for you. You may have the skill sets that mediate that well and that control all of the risks and so on. But let's just set up that's the consequence of not working down closely with the code base. The depths of your engagement is reducing. So broadly speaking, at the sort of the trends, the breadth of work is increasing, the engagement is thinning. So prompting is displacing coding, absolutely certain that this is happening across all organizations. That, in a sense, is the mechanism by which you get the productivity gains. Immersion in the roles, the task at hand is thinning. Code work is becoming mediated to some degree, depending on the level at which you're in that gradient. And the challenge here, the first challenge, is that understanding follows close contact with the code. So like, the engineering code-based knowledge is under threat now. We are not saying that that's terrible or inevitable. We're saying that that's a risk that organizations, and when we talk to enterprises, that's one of the risks they worry about. They worry about whether or not systems are getting fragile because their engineering teams don't really understand their code bases like they used to. So we have a slide here that tries to abstract that from down at the level of a specific engineer to the organization. So let's take on the view of the senior VP R&D of one of those kind of companies that we were talking about earlier. What are the challenges? The challenges are kind of almost topological. Understanding is becoming uneven. That's their starting point. So as AI gets used, the understanding of the code basis becomes thinner, not necessarily critically thinner, but thinner. So understanding of the code basis is becoming uneven. Everywhere that AI is being used heavily, that's where you're going to see the more significant. So it's a localized context gap that emerges. Okay. And where engineering teams have less of a handle on the intricacies of the code basis that they're managing, that inevitably leads to greater risk of fragility. Small issues might cascade. Few people hold the mental model of what the code really does. We all know what that looks like. So on the right, you see a sort of a depiction of that. Now, I hasten to add, this isn't like inevitable. We think this can be managed, but if we don't manage that issue, that's where we end up, and we don't want to. Nobody wants to end up in that place. So let's come back down again, and let's look at organizational culture, and how is it that culture is maintained and understanding of code bases is transferred across teams, and that kind of problem is not allowed to emerge, because that problem would emerge anyway if engineering teams hadn't developed methodologies to counteract it. If a particular part of a code base is only written by a few people in an organization, that's going to be a problem. So these are not new problems. AI is accelerating them, but we need to develop an understanding of it in order to be able to see how we counteract it in this new world. So what I want to do is I want to come back down to the level of reviewing, code review. Code review is a crucial part of organizational culture. It's an active gate. It stops bad code getting into the system. Okay, that's obviously its primary intent, but it's also a place where learning occurs, where junior engineers learn that code, what is expected of them when they write code, that certain cultural aspects of how we do things here, that kind of tentative knowledge is explained, and the day an engineer gets their first commit past review and into the code base is an important day, and in some organizations can take quite some time. So it's a gate, both of quality, but also a place where learning can happen. Okay, so what happens when the pace of code generation outstrips the capacity of an organization to deliver that kind of calibrated oversight? Okay, so you get individual impacting increasing. You've got the generation of code as a whole in the organization moving faster and faster and faster. And the risk, and I'm glad to say we don't see it in every organization that we deal with at all, but the risk is that the review process suffers under the simple volume of pull requests that are presented. So if an organization doesn't take care to ensure that it's still imbuing that cultural transfer and doing that gating at the review, then problems can arise. Now, it's worth mentioning here that there's clearly a role for AI in code review. And indeed, lots of tooling is being used right now to ensure that code that is submitted, perhaps written by AI, is also correct at some level. But there are limits to how far that can go. You can demonstrate code is correct, but not necessarily demonstrate that the code is appropriate in terms of overall design and engineering for the organization. So this question of whether or not the engineering teams are able to deliver decent oversight to the code development process has these two facets, and both are important. So in the worst case scenario, unknown code written by AI that really isn't understood by the engineers who produced it, clears the gate and ends up part of the system, which is all good until a problem emerges in that code base, and then nobody really understands what that code does and all that entails from that. So the risk here is that oversight, code review becomes a kind of a sort of a cargo cult thing, a form over function. It's done, but it's not really delivering the value that it used to. Now, an organization needs to work out whether or not that's important, and probably some aspect of it is, or indeed what they do about that and how they mitigate some of the negatives there in order to ensure that they maintain the kind of aspects of the process that they want to hold on to. So I want to move on slightly now to a sort of slightly different topic, which is, so what is an LLM? And I don't mean that sort of technically, I just mean that from an organizational point of view, is an LLM like an engineer? And we'd argue that an LLM is not an engineer. An LLM is a replacement for an engineer, or maybe a different kind of an engineer. Your engineering team is your engineering team because they have stuck around, they've internalized a lot of learning, they've lived through P1 issues. They have seen what breaks, what doesn't break. They've understood, they've absorbed the history, and they understand how the organization works. And an awful lot of what is right or correct in an organization is unwritten. The edge cases, the constraints, the purpose of systems, all of that stuff is hard to extract. Doesn't tend to end up in Confluence or Notion. It's shared in the activity of the team. In that kind of with that kind of a lens, an LLM is kind of more like an external consultant, a brilliant consultant who can generate marvelous code, but doesn't share that kind of history and background and that context that allows it to deliver code solutions that are on point for the organization, which is fine if the engineers have the capacity to capture that and adjust that and bring it up to speed, if you like, with the goals of the development team in the area that it is working in. But that, of course, as we spoke earlier, that depends on the degree to which engineers are still engaged in the actual process, or the degree to which they can capture that kind of organizational content in the prompting. And as I alluded to earlier, there are organizations that are doing this, but they are paying as much attention to that and devoting engineering time to that as others might have devoted originally to coding. So it's not a free lunch at all. Okay, so our point here, we're not going to try and tell you how you bring all of that together to do perfect engineering. Our intent here is looking at it from the point of view of senior management, trying to understand just what do they have in front of them. How do you manage this scenario? How do you govern it? How do you make sure that things are moving in the right way and capture the issues as they arise? And what we're going to get to is that governance is going to have to become a much more active investigative process, because LLMs have this capacity, GenAI has this capacity to disrupt so much of the existing development process, truly transformational and marvelous, but highly disruptive and needs to be understood. Okay, so in a way, from a manager's perspective, this can be boiled down to trust. Who do you trust? Because that's essentially how organizations work. Do you trust people? Do they have this? You don't necessarily need to know the detail, but will they? Do they have a capability to solve these problems? Every software development company in the world was built on trust of humans so far. We trust humans for context. We trust them for judgment. We trust them to write code that sometimes will be buggy. And we trust them to, providing we've done good selection and good training and so on, we trust them to deliver for the team. AI, we trust to deliver execution at speed. And that's kind of it. We know it's only going to be as good as the effort we put in, that it's an amplifier. It doesn't solve all problems. It amplifies the skill sets of the engineers using it. It's the practical reality. We also know that sometimes it's going to produce results simply because the guidance that we give it perhaps isn't as strong as it might be. That sometimes it's going to produce results that are suboptimal or even downright wrong, all the way through to, crazy stuff like you will see on X and so on all the time. And that stuff's rare, I think, but there is that end of the game too. So the key point here is we trust and verify. It is subject to scrutiny. You don't just assume that AI code works, at least not at the moment. And it's only at the very edge cases that people are starting to explore the use of AI in scenarios where no engineers look at code at all. The challenge here is that we're no longer dealing just with engineers and just with AI. What we're actually dealing with is this kind of hybrid. So different engineers, depending on the degree which they, and it typically is in organizations, the degree to which they find ways to introduce AI into their own development practice. are delivering outputs that are to some lesser or greater extent mediated by AI. And so it's a blurring. So it's not that you have the humans and you have the AIs and that you can kind of categorize what they should be doing. The real situation is you don't know tomorrow whether or not a particular engineer who never used to use AI, there are some famous examples of well-known computer science personalities who seem to have suddenly taken up AI and can't seem to get enough of it. So you don't know whether an engineer who didn't use AI before suddenly starts using it for everything, or whether a particular engineer is using it very well or using it very badly. It's a blurry kind of mess. And so the management challenge is how to apportion and allocate trust in a way that preserves their control and allows them to adjust as they go. The challenge is compounded by, and we're moving to kind of like the more practical end of things now. The challenge is compounded by this kind of problem is that regular metrics can look the same or better than before. But under the hood, things could be going kind of wrong. So let's just take some examples. We won't dig in too far, but your throughput could be increasing. You could be delivering more output, but at the same time, maybe your engineers understand the code base less. They're not doing the reviewing and all the rest of it. Okay, your test coverage could be increasing, but only because engineers are getting the AI to generate lots of test cases that are not particularly useful and not on point to the design goals. In other words, they're covering the fact that they didn't write test code before by generating lots of test code using the LLMs. Or they could be doing a great job, and that challenge is to know which. Cycle times could be shortening, but maybe only because people aren't scrutinizing the outputs of the AI as much as they might, either in a review process, or even the engineer themselves might start to rely too much on what the AI produces. The AI produces code most of the time that's marvelous. So why wouldn't it produce it brilliantly this time as well? And so become less sensitive to the possibility of AI generated code not being up to scratch. It will vary from engineer to engineer. And you could have stable merge rates, but you're not getting review depth. So these are examples. So essentially what's happened is that all of these metrics that we used to be able to reasonably confidently rely on because engineering was quite stable at the end of the day. And you didn't see huge variation from month to month or indeed year to year for particular engineers. These metrics now carry a bunch of what ifs. And that is a challenge. So where does this leave us? It leaves us with a kind of a gradient, which is that once upon a time, engineering management understood engineering because they understood the cognitive effort that was involved in the engineering activity. And they were able to see how those kinds of metrics mapped to shifts and changes in things like the difficulty of the work that's being done or the technical debt that's emerging in the code base. But once you start to introduce this kind of technology, it starts to kind of weaken the link between those kinds of decision-making, decision points, like we need to invest in reducing technical debt, against the kind of indicators that used to establish those kinds of cases. So automation kind of starts to manipulate or weaken the link, starts to become harder to understand. Metrics can stay green, whereas under the hood, the assumptions that you're making about the state of play aren't really mapping very well to the reality of what's going on. Now, it's not all bad news, obviously. I'm just pointing out that there are issues that need to be investigated here. And these are the kind of things that serious organizations worry about. So we need to start thinking about instrumentation and adaptation of our assumptions around how engineering is going. Now, at the kind of the multinational scale, this is not about whether or not a particular pull request is going to lead to a critical failure in some short time. This is really more about at a higher level understanding whether or not your SOC 2 certification is valid. This is about whether or not you're auditable, whether you still have processes which can tell you things about your engineering. Do you have instrumentation or oversight, really, that is meaningful? The challenge is that the problems arise kind of after after the incidents. Later on in the show, the problems arise. So, for example, code fragility is a problem that emerges after the code has become fragile, or your organization's capacity to manage the code has become fragile. So these are issues that really need management to front up early, rather than think about later in the cycle as a responsive thing, because it's probably going to be a little bit too late by then. So what we advocate is to think about the problem of what we call stewardship under automation. And what we're effectively saying here is there are obviously massive positives, but also potential negatives at an organizational level to how AI technology might hit the ground and be used. And you have to be sensitive to that, and you have to start building instrumentation that allows you to understand that and to proactively act. So, for example, to be able to identify where a lack of engagement with code bases is thinning an understanding of code bases, and actually reinforce oversight of the code being generated, not necessarily because the code isn't correct, but because the engineering team is losing an understanding of the code base. Just let's have more people reviewing code in order that they actually understand what code is being written. That's an example of a proactive measure that you might take in order to ensure that you're not ending up with a sort of a fragile code management context. You might need to actually dedicate people to owning subsystems, where you're feeling or seeing that, and sometimes it is feeling, but seeing that code is getting away from engineering. You may need to gate change where your measurement or your assessment is that things are weakening. So, if you can't validate, you slow it down. You give engineering more time to manage areas that are critical. You identify critical areas of code base, to be able to understand areas of a code base that are changing versus not changing using AI. All of this is important. The key idea is that comprehension of how AI is being used by the engineers across the code bases, you need to start thinking of that as an information asset. That understanding that is part of the game. The challenge, of course, as we've kind of alluded, is that some of the metrics that we traditionally use to understand engineering are well, they can deliver mixed signals. So there's an approach we think is appropriate here. First of all, you need to continue using these metrics. KPIs still matter, meaning isn't fixed anymore, but there's still meaning. And so that's important. You also, we feel, need to be able to identify and segment code that is being impacted by AI, and to different degrees, obviously, and in different ways, as we talked about, from code that isn't, and to understand where AI is actually being used, what it's being used for, where it's landing, what subsystems it's being used for. Is it being used mainly to maintain code, or is it being used to write greenfield code? All of this kind of detail is important to understand. You need to think about this problem as a time sequence problem. This is not about a static situation. Things are changing all the time, and so you've got to be able to and think about the management issue as being able to spot where assumptions you're making about the state of play are drifting from the reality. So this is a mindset that views signals and the generation of signals as something that needs to be continuously refined. As the organization changes, as new technologies come along, we have, for example, have seen with customers different performance numbers across the board, from straight productivity numbers to code quality numbers using different engineering tools. All of this can be seen if you start digging into the data, and changes as organization, adjusts to different tooling over time. And many organizations are still at the experimentation stage with lots of these technologies. So from our perspective, that stewardship problem, that idea that you have an analytics goal, that you need to understand a complex space, is going to require pretty deep data sets. So we view this problem, and always have viewed software engineering management as a deep data telemetry problem. You need to, dashboards are great, KPIs, Dora metrics are marvelous, but they're also very limited. And if you want to get beneath that, you need to unify all the engineering data. And I'm talking about everything: code commits, diffs, reviews, all the workflow data, AI usage, what engineer used what AI tool on what particular moment of the day. Detailed data sets are necessary in order to be able to build modeling on top. So like the main model, obviously, the most pertinent model right now for organizations that are starting to experiment and use AI technology in mission critical scenarios, are to be able to start to do commit level attribution, contribution level attribution. Which code was written by AI, which was written by humans. No, AI bill of materials, to be able to understand exposure to AI is actually starting to become an issue for even various supranational agencies in terms of legislation like the EU AI Act and all that kind of stuff. So that's your baseline, being able to understand what code was AI based, what code wasn't, bottom line. But then the more subtle question over that is to be able, and this will be very context specific, it will be very much about your organization, how to do time series analysis and shifts and performance indicators that you are using, either standard ones that you're maybe riffing off and developing further breakdowns on, or completely new analysis that are particular to your organization, and the particular goals that you might have. So the problem here, the challenge is to sort of say, okay, what are we trying to achieve with AI? How do we measure that? And to think of these data sets as being the data sets that allow you to develop, if you're working with us too, we'll work with you. But if with other organizations or doing it for yourselves, to start thinking about these data sets as something you can mine. This is signals intelligence data. You need to develop a thesis and build some hypotheses and start testing them by instrumenting and gathering and processing these kinds of data sets. And I can tell you that what I've certainly seeing at sort of enterprise level is that organizations are doing this. They aren't simply just jumping headlong into using these kinds of technologies. They are very carefully thinking through the impact of these technologies, and everybody we're working with has some level of in-house outfit, teams that have certainly started to explore this kind of stuff. Whether we can add something to that or not, obviously, is an interesting conversation. It's outside the context of this conversation, but real teams are doing this kind of work, and I think that's important to emphasize. Anybody new to this, anybody starting to think about getting into this, needs to be aware that this kind of analysis is actually an important part of delivering real value with this kind of stuff. So we're talking about is inquiry first granularity level data, really detailed, and that allows one to run things over it. So dashboards are not enough. They're great. But you need to be able to explain what's going on, and that requires a deeper analysis to be successful. Our approach to this problem is built in 3 layers. We provide the dashboards. We'll show you at the everywhere from the organization down to the individual, the teams and the groups, everywhere in between will show you like how Cursor versus Copilot is impacting your PR cycle time, how much time is being spent on review as opposed to coding time, all those kinds of breakdowns by tooling across organizations, different parts of an organization, across repositories, every kind of breakdown you can imagine. We're providing in our dashboard, see our site for further details. But moving a layer up from that, the next layer is to think of all of that data that might be used to deliver those kinds of dashboards, which are effectively opinionated views on what is important, and therefore not necessarily what's going to be important to your organization, because it's a highly contextual space. A data lake, just to see all of that data as a data lake. So we provide tooling, user interfaces that allow one to develop your own analytics over the kind of data sets that our systems gather. So gather all of the data you can imagine and then bring that all together into a unified data lake that then becomes an asset that you can start querying against. And that is proving to be very, very useful for many of our more sophisticated customers. We've recently introduced an additional element to this stack. We've introduced LLM exploration. So we've started to allow customers to be able to run a kind of free-form interrogation, kind of like chat sessions. Tell me about the engineers that are struggling most with delivering pull requests, or that, with critical failure, this and that, and so on. Sort of like, you can kind of come up with hypotheses, test them. And we feel that this is going to be really important. We're kind of, the response has been really interesting. The ability to sort of not have to invest significant time in instrumenting particular analytics, but to be able to ask free-form questions and let the LLMs do the sort of the mapping from hypotheses and kind of what-if scenarios down to the data, is turning out to be a really interesting way for people to explore just what is important. And rarely a day goes by when someone hasn't found something interesting about their organization that they didn't anticipate. It can be quite surprising what can come out of that kind of free-form data analysis. It's all built on the same underlying data lake. So turning out to be quite interesting. Anyway, that's our model for it. I suppose what I would say at this point is that there are lots of possible models for doing this, but they are all going to be based, we feel, on going beyond normal KPIs and approaching the problem not as a sort of a summative KPI approach, but thinking of it more as an investigation, where data is your friend and investigation is your main tool. So my final message, and happy to take questions. If anybody has any questions, we can get into it. AI is a superb technology. It is changing engineering. We're absolutely not saying we shouldn't be using this. Everybody should be using AI technology to do software engineering, we feel. But it does have consequences, and they shouldn't be underestimated, and that needs to be managed, unless you're building an app. If you're doing anything that's mission critical of scale, if you're managing someone's pension fund, stuff like that, you can't be just hoping for the best. You need to think about this as a highly disruptive technology that's changing pretty much everything about your existing development methodologies, and you need to plan for a highly adaptive, changing environment that you're going to need to instrument and understand. So velocity has to come with an understanding of how that velocity is impacting. You really do need to understand that if you're going to maintain the kind of performance and quality that you've done with humans. Bringing AI in is going to accelerate your process, but unless you do it well, is going to cause problems for you. And what we're saying is that they can be managed and they can be solved. It just needs this kind of approach to governance. It needs to be deliberate, as we were saying in the final point here. And that's me. I am finished with my spiel, so I am happy to take questions. Well, it doesn't seem to be any questions, but thank you all for attending. By all means, reach out to us if we can help you in any way, or if you want to shoot the breeze and talk about software engineering. We love software engineering, and we're always happy to talk. So many thanks for your time, and see you next time.